This talk is called Molecular Compounds. To be honest with you, I kind of like the word covalent. But your book likes the word molecular. So get used to hearing the word molecular. Ooh, let's see what color I'll make it. Or covalent. Okay? Molecular or covalent. Okay? I prefer to call them covalent, so I'll start saying covalent. But understand that the book's talking about molecular compounds. Okay, and so we'll be talking about chapter 8.1 briefly, and then 9.3, which is actually naming. So by the end of this, you'll know how to name all these compounds quite easily, actually. Okay? So, learning objectives. Number one is just a basic understanding, and by basic I mean basic understanding of covalent compounds and their properties. Okay, quiet please. A little bit quieter. Okay? And then understand the basics of a molecular formula. For all of you, this is really easy, so you'll be like, okay, this is pretty straightforward. And then the last one will just be, how can we name these compounds? And this is the naming that you guys wish you could have done all along with the other ionic compounds, so this will actually come quite easily to you, okay? So, let's talk about molecular compounds. Okay, they are basically compounds that are made from nonmetals. And again, they're called molecular or covalent compounds. So obviously the key word is nonmetals. You guys should know this by now, backwards and forwards, okay? And it occurs when two or more elements share electrons. Key word is, oops, never mind. Key word is share, okay? And again, they still want to achieve stable octets, just like ionic compounds, but covalent compounds achieve octets around each other by sharing electrons. So you'll see each of them will have 8 electrons around, but the total amount of electrons won't be 16. It'll be less than 16. It'll be 14 because they're sharing 2 electrons to make their octets, okay? And so where they share, it turns out that where they share and where the bond is actually an overlap of their orbitals, so it's right in this little area right here. So you see the 2 atoms come up, and they actually get close to each other, and they're actually sharing, and if there's a single bond, they'll be sharing 2 electrons right in between them like that. And that's known as a covalent bond, okay? And we'll talk a lot more about that bonding pretty soon. Yes? Generally, most metals don't. Most metals just lose their electrons to other things. But, I mean, there's probably lots of examples of where metals can share electrons as well. Okay? So we'll spend a lot of time talking about covalent bonds and dipoles and hydrogen bonding and intermolecular forces and all sorts of things. But for right now, we're going to just talk more about the properties of these compounds. Okay? So we've talked briefly about this, but again, let's just go over the properties of molecular compounds. And as you see these properties, remember that the properties of ionic compounds are about 180 degrees opposite of these guys. Okay? So the first one is low melting and boiling points. So these compounds have low melting and boiling points. You know this, for instance, if you open a can of paint, you immediately have a smell. That's a covalent or molecular compound that's coming into your nose. Nail polish remover, you take off the lid of that, the cap, you'll have an immediate smell. It's more than likely you're smelling acetone. Okay? It's a covalent compound. So anytime you have this kind of what people would refer to as a chemically smell, you're probably talking about a covalent compound. Ionic compounds like salt doesn't really smell. Doesn't really have a smell. Not really. Okay? And so the reason is because they have low boiling points. It doesn't take very much heat for them to become a gas. And so you will smell that gas. And they mostly exist as gases or liquids at room temperature. This is actually, I think I modified the slide in another version of a PowerPoint I have similar to this. But it's safe to say that there are also a lot of them are solids as well. So really they can be solids, gases, or liquids at room temperature. They have a far greater expanse of physical properties in physical states than ionic compounds do. Ionic compounds generally are just solids. Okay? A lot of them are liquids at room temperature. Okay? So make sure you put solids in there as well. And of course, as we said many times, they're made of nonmetals. That's obvious. And again, when you see these polyatomic ions, keep in mind that those polyatomic ions are made with covalent bonds as well. Even though they might participate in an ionic bond, the things that hold the sulfur and the oxygens together in sulfate are covalent bonds. Okay? And they're molecular compounds. Okay. So let's just talk quickly about molecular formula. I think most of you will understand this. So compounds have these things called molecular formulas. So these are just kind of like the algebraic equation that it expresses a molecular compound. And here's some really obvious, easy examples. CO2 means 1 atom of carbon and 2 atoms of oxygen. So this is pretty rudimentary stuff. And of course, H2O means 2 atoms of hydrogen and 1 atom of oxygen. Now, molecular formulas can get quite complicated. It'd be like C24H36N3O6SCl. It's pretty, and as they get bigger and bigger, molecular formulas don't mean nearly as much. And they don't tell anything about structure, okay? Don't tell anything about structure. So just keep that in mind. This chapter goes over this, so it's pretty easy stuff. Pretty easy. Now, this is the part where I want to spend a little bit more time naming molecular compounds. So, the first rule is that the first element is named using standard name. So I'll give an example. So if you have CCl4, the first element is using the standard name. So the standard name would be what for this chemical, for the first element? It'd just be carbon. You'd write carbon. Okay, so you're good. Okay, so that would be for CCl4. Somehow this name is going to start with the word carbon. Okay. Now let's go back to the next rule. It says the second element prefixes are used to denote the number of atoms present. Okay, the number of atoms present. So it seems like in our example of CCl4, we're going to have carbon and then some kind of prefix and then the Cl at the end, okay? So some kind of prefix that denotes 4. Can anyone give me a prefix that denotes 4? Quad, that would be wrong.
Tetra.
Tetra, yeah, it would be tetra. Where did you find that, Matt?
On the back of my periodic table.
Oh my gosh, everything's there. On the back of his periodic table. Because it's a cool word. That's why Tetris is called Tetris, because they're all 4 blocks. That's why.
So much sense.
Actually,
Tetra. Okay, so it's going to be carbon tetra. And then anyone want to guess? There's one more rule. What do you think this will have for its name? Chlorine, I guess. Chloride. Yeah, it'll be chloride. Carbon tetrachloride. Okay? So let's see what the last rule is. The last rule says, yeah, we name the second element with an IDE ending. Okay?
That's always.
Always. Always. Now, that's something to keep in mind, people, when you look at this, not, all these covalent compounds. And covalent compounds, if there's 10 million known compounds, they make up about 95% of the known compounds. But if you actually go to the periodic table, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to 13 elements that make up all these compounds. So basically, only 12 or 13 of the elements make up about 95% of the known compounds. Does anyone want to know why that is?
Makes it easier.
But why? Why?
Is there more? No.
There's actually one element is the reason why.
Carbon.
Yeah, it turns out carbon. Carbon basically can make 4 bonds. It makes a tetrahedral bond, and it just can make changes and rings and all sorts of things, okay? So that's the main reason why those few nonmetals make up most of the compounds. Kevin?
Is that why they call it the element of like life?
It is the element of life. Absolutely. It's organic. The word organic means, it's carbon. Okay? So it's basically anything that's alive has carbon in it. Okay? So, one of the first interesting things is this one. Don't use mono on the first element. So I'm going to give you another example. Let's see if you guys can name this chemical. CO. What's the name of this chemical?
Carbon monoxide.
Carbon monoxide. I'll call it carbon monoxide.
Got him.
Monox. That's deadly.
Notice it's not called monocarbon monoxide. So if it was 2 carbons, we'd say dicarbon oxide or something like that, but we don't use the mono prefix on the first element, only on the second element. And there's actually people that are a lot of people that aren't using it on the second anymore. A lot of people are trying to say this is carbon oxide. It's not sticking though. That's that way to name. Okay. And so here's your prefixes. As Matt said, you can find them on the back of your periodic table: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay? There they are. This should be pretty easy. Okay? Pretty straightforward? You think you can name them? Okay. Don't leave yet? Okay. These are on the back of your periodic table, Eric. Okay. Yeah, nonagon. That's what it's called.
I thought it was monogon. It's like a non-agon.
Okay. So why don't you guys go ahead. Here's your homework.